So far, what we have learned with our simple linear regression analysis, or SLR, is that we would have to do a scatter plot so that we can know the visual description of our data, and we also have to know our regression line so that we can see if there is actually a trend, or there is a line rather, that will pattern the trend from the scatter plot. And now we have to look at the regression equation. Regression equation, which we have learned previously that we will have y hat is equal to beta sub 0 hat plus beta sub 1 hat x. We can actually interchange this, so this can also be y equals beta sub 1 hat x plus beta sub 0. So now, how do we produce this line in Excel? So again, we will go to our chart and we would select this again. Let's just take a closer look here. In our trend line, we would have this one here. Now, in more options, let's just zoom out. Here, in our more options, we select this button, which is the trend line options. So here, oops. So here, wait a moment. So here, you can see we have the following down below. So in the trendline options, you scroll down until you see this. So now, we will select display equation on chart. So once we click that, we would have the equation here. There you go. Let me just select it down here. Then let me just make that big. Oops, wait a moment. Let's select everything. Make it 14 and bigger. There you go. So this is now our regression equation. Y is equal to 3x plus 19.2. So what does this mean now? Remember, when we interpret the 3 here is our beta sub 1, which means for every 1 unit increase in dexterity score, because that's our x, dexterity score, there is 3 unit increase in the unit produced per hour. So that means the more I would increase my dexterity score here, then I would actually have additional 3 every time. 3 more units every time I would do something. So if I would increase my dexterity score by 1, let's say if my dexterity score is 10 and I would make it plus 1, so it would be 11, then whatever my number of units produced here, it will be plus 3. That's what this means for our beta sub 1, 3. For our 19.2, this means that if my dexterity score is 0, that means I can actually produce 19.2 units. So if my dexterity score is 0, though that does not mean I don't have dexterity, that just means that the score I got in the test is 0, I can still produce around 19.2 units. That's what this means. So now it depends on the situation whether that's actually interpretable or not. But here we were able to interpret it. So that is now the nature of the relationship between the dexterity test score and the units produced per hour, or the productivity based on its regression line, and the equation of the regression line. So we have our equation like this. Most of the time, statisticians would write it in this way instead of the simple y equals 19.2 equals 3x, or y equals 3x plus 19.2, they would prefer to have this instead, that the productivity, or we can just have P, is equal to 19.2 plus 3 times the actual variable's dexterity, or the productivity, so that it's very clear to the readers, even though there are non-statisticians or non-statistics students or non-statistics people, that we can predict productivity using dexterity. We can actually try to estimate the productivity based on the dexterity. Say for example, let's try to predict the productivity of an employee if the dexterity test score is 24. So, what would happen? Our productivity value would be 19.2 plus 3, following our formula here, then times 24, which is our dexterity test score, and we will have a 91.2. So, what does this mean? This means that if my dexterity test score is 24, I'll be able to produce around 91.2 units of whatever I need to produce. So this is my predicted number of units produced per hour. So we can actually use the regression equation. The regression equation can be used for prediction, because the regression equation is already the nature of the relationship. So if this is the actual relationship of our variables, then we can try to guess what will be the other variable based on our given independent variable. However, do take note that prediction for y given x should only be within the values of x in the sample, which would mean the prediction only works the prediction only works on that given sample. So again, so far what we had in our simple linear regression analysis is our scatter plot, our regression line, and our regression equation. And more of them are more on the nature of the relationship. We would need this time to see the strength and whether the relationship is actually significant or not. And we will look more into this in the next videos.